The question 11 of exercise 5.6, I am taking 5.6 question number. Yes, but Bhavi sir? Hello? Is it okay? So here this question was like that y was given to be equal to under root of a cos inverse t, and x was given to be here under root a sin inverse t, a sin inverse a raised to power rather a sin inverse t, and you have to prove that dy by dx is nothing but minus y by x. So here see, what we are doing is that yes, now see, simple it is, dy by dt here, what it would be? It would be d by dt of this thing. So d by dt I am straight away writing under root of this whole thing, you will put some variable p. So under root p is what? 1 upon 2 root p, that is a cos a raised to power, this is a cos inverse t. It is not here, it is in a cos inverse t, please see to it. And then see into the derivative of this thing, a raised to power cos inverse t. So derivative of this thing will be what? A raised to power cos inverse t into log of a, and then derivative of cos inverse t. So that will be precisely minus 1 upon under root 1 minus t square. So this whole thing will be the derivative of y, and likewise here the derivative of x will be what? Dx by dt. Please see, it will be again under this a sin inverse t you will put equal to p. So root p is what? 1 upon 2 root p. So root p is what? Precisely a raised to power sin inverse t. Then derivative of a sin inverse t, a derivative of a sin inverse t. Here you will put sin inverse t is equal to q. So a raised to power q, its derivative will be what? A raised to power q into log of a. So with that understanding, it will be a raised to power sin inverse t into log of a, okay, and then derivative of sin inverse t, because you have your here internal function was sin inverse t. So that will be 1 upon under root 1 minus t square. Now obviously see here, dy by dx is what? It is dy by dt upon dx by dt. So what you are seeing is that t will cancel, log a will cancel, and this 1 minus t square will cancel here. And what you will be left with will be dy by dx here. And we see it is under root a raised to power cos inverse t, a cos inverse t. So here you will get under root a cos inverse t upon, likewise there what you will get is minus under root a raised to power sin inverse t. This is nothing but minus y, and this is equal to your x. So this is how you are going to prove it. Now next is our second exercise, that is second derivative, means that you have to differentiate once more. Please see, students. Now I am taking this second order derivative. It is your next article, and it doesn't amount some new theory. Only the old one you have to apply. Only what is the difference will be is that you have to differentiate it twice. First you will find dy by dx, and then see you will find d2y upon dx square. So now you have to find the second derivatives. Second derivatives is denoted, symbol is d2y upon dx square. At times it will be denoted by y double dash, and at times it will be denoted by y2. So please remember all these three symbols, they will be referred for obtaining the second derivative of the function. Second derivative of the function. Now please see, I will take here, and this constitutes your exercise 5.7. See, there is hardly anything difficult in it. We will just take few questions here. Okay, first see, all the first 5-6 questions, they are too easy. Okay, let me take question number 5. Question 5. Okay, d by dx of x cube log x, x cube log of x. Okay. Now please see how we can find it out. It is the product of two functions. So it can well be written to be what? First function into derivative of second, that is 1 upon x plus second of log x into derivative of first, that is 3 and then x is squared. Now so this will fetch you what? This is equal to how much? It is x squared plus 3 log of x and x squared and x squared. Yes. Now here see again you have to differentiate this whole, because this is d by dx of your function x cube log x. This is this much. Now you are differentiating again with respect to x. So what you will get is x cube log x. Please see, you are differentiating x square, you are getting 2x plus 3 is okay. It is again the product of two functions, first and second. So now here see, this one you take first, this you take second, and then apply it. So first function into derivative of second, log x derivative is 1 by x plus log x and derivative of this thing. So this is 2x, 2x. So this is what you will get as answer, plus 3, and this is x only plus 2x log x. So 3x, 2x, 5x plus 2x log x. That would be the answer. So you have hardly to do anything new, only you have to differentiate once again. For obtaining the second derivative, what you need to do is that you have to differentiate once again. So these there is hardly any new theory involved here again. Now you will have your this standard derivatives, and you have to simply invoke the formula your this derivatives of standard functions. I take next question here. It is say question 10. Okay, let me take it. So very simple. What it is? Sine log x. Sine log x. Now y is equal to sine log x. So dy by dx. What it is? It is dy by dx. What it will be? See, internal function is log x, that has to be kept as t. So sine t you will be differentiating with respect to t. Derivative of sine t will be what? Cos of t, that is cos log x into derivative of log x with respect to x. So this will be 1 upon x. This will be 1 upon x. Okay. Now see what it is. You have to differentiate once again. So what you will do? You will want, now it is product of two functions, first function and second function. So what you need to do is that you apply the product rule for obtaining the derivative here. So for obtaining this derivative, what you do? First function, it is cos log x, okay, into derivative of second. Derivative of second is what? X raised to power minus 1. So minus 1 into 1 x raised to power minus 2 plus 1 upon x, that is x raised to power minus 1 into derivative of this thing. What will be the derivative of cos log x? It will be minus sine log x, and derivative of log x is what? 1 upon x. So this will be the answer, minus cos log x upon x squared, and then this minus again, and 1 upon x is 1 upon x squared, and then it is sine log x. Sine log x. So this would be the answer. If you take minus sign common, then you will be plus over here. So simple it is. Now look in the question number 11. Question number 11. Yes. It says that if y is equal to 5 cos y is equal to 5 cos x minus 3 sin x, then you have to prove that d2 y2 plus y is equal to 0. Hold on. Yes. What you have to prove? y2 plus y is equal to 0. Means y2 is what? Second derivative. Second derivative. Okay. So let us differentiate this thing. It will be simple. So dy by dx, or you can equivalently write it y1. So y1 will be what? Minus 5 cos x is sin x, and minus 3 sin x is what? Cos x. Okay, then second derivative y2, that is d2y upon dx square, what it will be? Minus 5. Derivative of sin x is what? Cos x, and minus 3 cos x is minus sin x, so it will make it sin x. Okay, so this thing, if you take common here, so it will be 5 cos x minus 3 sin x, and this is precisely minus y. So y2 is equal to minus y. So please see, you put the value here. At place of y2, what you will put? Minus y plus y. These two cancel and you will get 0. So this is quite simple, hardly anything to do. Let us see other good questions here. There is hardly anything new again, repetitive in you. Okay. Now let us take question 12. Now see 12 onwards we have this question 12 is good one. Question 12. What it says? Please see. Find d2 y is equal to cos inverse x. Y is equal to cos inverse x. Then you had to find d2y by dx square in terms of y alone. You have to find y2 in terms of y alone. Okay. So what you will do? You will find dy by dx. Dy by dx, you can equivalently write y1. So what it would be? Cos inverse x is what? 1 upon under root 1 minus x square. Okay, so this is y1. Let us find d2y upon dt square. Let us differentiate it once again. So let us see what we will get. It is minus. Now what it is? It is in the form of quotient. It is in the form of quotient. So what you can write better is that it is, yes, quotient root minus you can take outside from being constant. So it will be denominator square. So what you will get? 1 minus x square. Then denominator, that is 1 minus x square into derivative of numerator. Derivative of numerator is what? 1. So d upon dx of 1 is what? 0 minus numerator 1 and derivative of denominator. What is denominator? D by dx of under root 1 minus x square. Please see, d by dx of under root 1 minus x square. Here see this whole thing you will put first of all equal to t. So what you will get? It will be d by dt of under root t into dt by dx. Okay, t you have kept to be what? Under 1 minus x square. So it is 1 upon 2 root 2 into dt by dx is what? Minus 2x. T value will put, so it will be, please see, derivative of this thing is nothing but 1 upon 2 under root 1 minus x square into minus 2x. So this minus will make it plus, you can put it here, so minus, this is 0, minus minus plus, 2 cancels, and what you get is minus x upon, yes, under 1 minus x square and under root 1 minus x square. Okay, this is what you are getting. Fine. And what you have to show? You have to show that okay, then let us see what it this amounts to. Dy by y1, okay, d2y you are differentiating 1 minus x square. We did something cos inverse x, okay. Fine, it is 0 minus x upon this thing, okay. So you keep it as such now. So this will give you what? X upon 1 minus x square raised to power 1 plus. So it is 1 minus x square raised to power 3 by 2. Okay. Fine. So what we can do now, please see. Okay. So x will be, you want the answer is in terms of x only. Fine. So let us see. Okay. So x is what? See, x will be cos y. Please see from here, y is equal to cos inverse x. This implies x is equal to cos of y. So here put the value of x here. So this will give you cos of y upon 1 minus cos square x, that is sin square x. So sin square x and sin cube x rather you will be getting. Sin cube x you will be getting. Okay. 1 minus x cos square x, okay, fine, and this is 3 by 2. So 1 minus cos square x is sin square x, and 3, so you are getting this thing, okay, fine it is. So 1 minus cos sin, okay, so cos upon sin is what? Cot of x, and 1 upon sin square is what? Cosec square, sin, it is y, sin cube y, so cot y cos square y, that is the answer, please see, that will be the answer. It is cos y upon 1 sin you are retaining into 1 upon sin y, that sin y you are retaining in cosec square y, so cot y into cosec square y. That will be this is answer strictly in terms of y, and that was the requirement of your question. So now we move to the next question. Simple question they are. Question 13, please look in. It says, if y is equal to, please see, 3 cos log x, 3 cos log of x plus 4 sin log x plus 4 sin log of x. Okay. Then show that x square y2, then show what? You have to show x square y2 plus x y1 plus y is equal to 0. Okay. So differentiate this thing, what you get is y1. y1 is first derivative. So differentiate it 3 cos log x. First you will log x you will assume t cos t. Cos t is what? Minus sin t. So minus sin of t. T is your log x, and then derivative of log x with respect to x plus. Likewise here 4 sin log x will be what? 4 cos log x into 1 by x. So it is this much of thing. So this is that first derivative. Now you have to find the second derivative, okay? So second derivative, let us find it out, no issues. It is here, if we find the second derivative, that is second derivative is y2, then please see what we have to differentiate it. So minus 3 will be outside, it is sin log x upon x. So it is in the quotient form. So quotient denominator is square. Now see what? Denominator into derivative of numerator. So numerator is what? Cos log x, and log x is what? 1 upon x, and then minus how much? Please see sin log x, that is numerator into derivative of denominator, and denominator is what here? X, so it will be only 1. So this is x here, this is x here, fine. So this is all about the derivative of this thing. No, so fine. So this much of thing you will get, okay. And then likewise here, 4 you can take common, and it is the derivative of cos log x upon x. So again see quotient rule you will apply x square and then denominator derivative of numerator, that is sin log x into 1 by x minus cos log x and derivative of denominator, that is 1. So those whole thing is like this. Now you can simplify it. What you are getting is minus 3 cos log x minus sin log x upon x square. Okay, and here you will be getting how much x, when this x will cancel over here. Okay, so 4, and here you will be 1x will cancel here, so you will be getting minus sin log x, and here also minus cos log x upon x square. This is your second derivative. No issues. So what you want to show is that x square y2. So first you multiply this thing by x square. So what you will get is x square. This x square will multiply with by 2. You will get x square. So minus 3, and what you are going to get is here is yes cos log x minus sin log x. Okay, and then it is plus 4 times minus sin log x minus cos log x. Okay. So this is the thing. Now x square y2 you have already gotten it, x y1. Let us see what we will get by obtaining x y1. Here see x y1. If you multiply this equation, here see only see this much of thing is coming. So this x y1 is how much? So from here, suppose this is 1. So from 1 what we are getting is x y1 is equal to how much? Please see minus 3 sin log x minus 3 sin log x. Okay, and how much? Plus 4 cos log x, plus 4 cos log x. Okay, and then plus y. Okay, so let y be equal to y only, and at base of y I can put this much of thing. So y is equal to how much? 3 cos log x plus 4 sin log x. Now if I add here, so on the left hand side, my left hand side is precisely what is the question, x square y2 plus x y1 and this thing. And please see here everything will cancel up. See plus 3 sin log x, this will cancel here, and this minus 4 cos log x will cancel from here, and this minus 4 sin log x will cancel from here, and this cancels from here, minus 3 cos thing. So this is equal to 0. Proved. So simple questions, simply you have to put the values, nothing beyond that. Okay. Now next question, please see. Let me do the question number 14. Yes. Question 14. If y is equal to a e to power x, y is equal to a e to power mx, okay, plus b e to power nx plus b e to power nx, then show that d to y, yes, then you have to show that y2 minus m plus n y1, that is dy by dx plus mny is equal to 0. Mny is equal to 0. Mny is equal to 0. Is the board visible? Bhavya sir? Bhavya sir, is the board visible? Sir, not so clear. Still not? It is not visible? So you should have told me earlier. Okay, it needs a little bit of setting. Just to hold on, just hold on. Is it okay now? Just a minute, I had to place my. Just. Sir, now it's okay? Okay. हाँ सर एक मिनट सर अब ठीक है हैं देन शुड आई कंटिन्यू बच्चों स्टूडेंट शुड आई कंटिन्यू भाभी सर बच्चों से पूछिए वो ठीक कह रहे हैं चलिए ओके नाउ दिस क्वेश्चन y is equal to a e की पावर mx plus b e की पावर mx you have to show this thing is equal to 0 so differentiating y1 will be equal to what please see a is a constant e raised to power mx you know that the derivative of e की power x is e की power x. Now mx you will put t. So e raised to power t is what? E raised to power first you will write mx and then derivative of mx that will be m into plus likewise here that this derivative will be what b raised to power e nx you will put some other variable t. So e raised to power t with t you will differentiate so you will be getting the same thing and into n you will get. So this is first derivative. So this is what you can write is ma e raised to power mx plus nb into e raised to power mx. This is your y1. Differentiate once again. So what you will get is y2 it is ma is constantly c and then derivative of e raised to power mx will again be what m is m into e raised to power mx plus likewise e that this nb is constant so derivative of e and x likewise as earlier will be what? N e raised to power n x. That n get multiplying with here will give you n square b e raised to power n x. Now this is quite simple. You want y2 minus m plus ny. M plus ny. So, okay. Let us put the values here. Y2 plus m plus n minus m plus n y 1 plus m and y. Let us find this value. So y2 is this much of thing, m square a e raised to power mx plus n square b e raised to power nx. Please see, this is the value of y2 which I have kept here at place of y2 minus m plus n at place of y1. I am putting this much of value. So this is obviously m a e raised to power mx plus n a e raised to power nx, and then what is m and y plus m into n, and at place of y I will put my this thing a e raised to power mx plus b e raised to power mx. Now see, let us see if everything is cancelling out here, and it will. Please see, okay, let me just write one second, simplify this bracket, and then I will show you n square e raised to power mx minus. Please see, let us be, I am multiplying with m. So m multiplied with m will give me what? Minus m square a e raised to power mx, and this m with this n will give me what? Minus mn a e to power nx, and then n with this thing will give me what? Minus mn a e to power mx, and then finally it will give me mn n square, this thing n with this n square a raised to power e to power nx plus this whole term, plus let me write better, mn a e to power mx plus mn b e to power nx. Now see, very easily, m square a e mx will cancel with this thing, n square e b x will cancel here, this mn a e to power nx will cancel with mn this thing, mn a e to power nx will cancel this thing, and you will get 0. You will get 0. So hardly anything, only simple practice of derivatives, and then simply putting the value in the equation. This is what you will. I feel that there are not much very difficult questions in your book, barring one or two. So that you had to be particularly. But see, since this is the beginning, maybe that you may find a bit, a little bit of this thing, a difficulty you may encounter, but with a little bit of practice, see, I think you can do it easily. But remember, whenever you find difficult in doing the problems, then please resort to the complete method. That is for, especially when you are taking the derivative of the composite function. Then see, if still you have not been able to acquire the practice, because you can write directly also. When you have practiced the thing, that is when you are fully aware that what is the innermost function, then what are the intermediate function, and then what is the outermost function. So what you will do in the outermost function, the rest of the things you will assume t, and the outermost function you will differentiate with t. Then see the rest of the function. You will again split it into two parts. The outermost one, then the last but one outermost, and the rest of the things again you will assume to be some variable p, and this last but one outermost function you will differentiate with respect to the new assumed internal function, and this way the process continues. So if you can't do it right now, then please resort to the complete method. So that would be the way out till you have not acquired the perfection. Now see, this again this question is the easy one. I am skipping it out. It is almost on the same lines. And let me take the 16th question, though it is also on the same lines. Question, okay, let me do 15th also so that you don't feel any difficulty. Y is equal to how much? 500 and e raised to power 7x, e raised to power 7x and plus b 600 e to power minus 7x plus 600 e to power minus 7x. Remember students, whenever you have derivative of e to power mx, d by dx of whenever you have to write e raised to power mx, then remember it is always m into e raised to power mx. Reason being, mx you will put t, okay? So this thing will become c. E you will put e to power, sorry, mx you will put t. So this will become e raised to power t. So d by dx. So d by, this is d by dt e to power t into dt by dx. And this dt by dx from here is what? M. So this value you put here. So e raised to power t and t is what? Mx. And this is m. So this is, you can remember also because this is how you would be getting the results. Now here we will be doing the same thing. So first derivative will be what? y1. First derivative y1 means dy by dx. So this is y1, as I said. It is 500 into derivative of e to power 7x. E to power 7x will be what? 7 into e to power 7x plus 600 into e to power minus 7x. So it will be what? Minus 7 e to power minus 7x. Okay. Now let us take the second derivative, that is dy upon dx square. So this is to be written as y2. Any symbol, whichever you feel like, you may use it. And please see, this will become what? 500 into 7 and e to power 7, this derivative, so because this all is constant, so e to power 7x, so again you will get 1 is 7 and it is e to power 7x plus, likewise here 600 minus 7 is square and e to power minus 7x. So you have obtained the second derivative, you have obtained the first derivative, and you have the function itself. And what you want to show is that d2y, y2 is equal to 49y. Okay, you have to show what? y2 is equal to 49y. This is what you want to show. Okay, so d2y is this much of thing. Okay, so now here see, here you take 7 square common. So what you will get? You will get 500 e to power 7x and plus 49 here plus 600 into e to power minus 7x. And this is what? 49y. So this is your y2, you get the result. y2 is equal to 49y. Simple. There is hardly anything, only a little bit of practice will fetch you the answer straight away. That is, in your miscellaneous, what I find is that there are few questions which are good ones. You can try the question from sampler. Students, there is one sampler where you will find good questions. You can try the questions therein also simultaneously. Okay. Now, let me take question number 16. Question 16. Okay, e to power y x plus 1. E to power y x plus 1 is equal to 1. Show that is equal to 1. Show that y2 is equal to y1 square. y2 is equal to y1 square. Okay. Let us see how to do it. Please see, let us differentiate this equation. Let us see what we will get here. Okay. Okay, differentiate it with respect to x. So left hand side, d by dx, please see how you will be doing it. E raised to power y x plus 1 is equal to d by dx of 1, that is 0. Now this is is the product of two functions, first and second. So first function, it is e to the power y into derivative of second. This derivative is 1 plus 0 plus x plus 1 into derivative of e to the power y. Please see, what is the derivative of e to the power y? Please see, it has to be written d by dx e raised to power y. And so it will be e raised to power y 1, 0 plus x plus 1 d by dy now, because y is again a function of x, and so d upon dy ey into y dy by dx, and dy by dx what you will prefer writing is y1. So it is e raised to power 1 plus x plus 1 e to the power y into y1. 1. It is 0. It is 0. So this is what you have obtained now. Okay, and what you have to show y2 again. Okay, y1 you have obtained, you have to find y2. Okay, so basically y1 what you are getting is y1 is nothing but minus e raised to power y upon e raised to power y x plus 1. Please see, e y cancels. So y1 is 1 upon x plus 1, and therefore y2 is equal to y1 is square. Okay, so y2. Okay, let me differentiate once again. So this is function of function. So x plus 1 whole is square, and then x plus 1 denominator derivative of this thing 0 minus 1 into derivative of this thing, that is 1. So this is what minus 1 upon x plus 1 whole square. This is equation 2. This is equation 1. Okay. Obviously see y2, and it should be, as a matter of fact, you see there was one negative sign over here also. So this negative and this negative will become plus. Please see, we skipped one negative sign here. So this is plus 1 upon x plus 1 square. This is 1 upon minus 1 upon x plus 1 square. Obviously y1 square will give you what? 1 upon x plus 1 square, which is equal to y2. So done. So this is simple here. All questions here are too simple. Now, we will take the last question here. If y is equal to, please see what it is, tan inverse x square. Tan inverse x square. Then show that x square plus 1, x square plus 1, y2 plus 2x and x square plus 1, y1, x square plus 1 and plus y1 is equal to 2. Okay, so this value we have to calculate. Fine. So y is equal to tan inverse. So y1 will be how much? It will be tc. Tan inverse x you will put t square. T square you will differentiate with t. What you will get? 2t. And 2t, t is what? 2 tan inverse x. And the internal function is to be differentiated with respect to independent variable. So it will be 1 upon x square. So this is the value of y1. This is the value of y1. Let us differentiate it again. So it is in the quotient form, tan inverse x upon this thing. So its derivative, for obtaining the derivative, what we will, the quotient rule we will apply. So 1 plus x square into derivative of tan inverse x. So this is 1 upon 1 plus x square minus numerator, that is tan inverse x into derivative of what? 1 plus x square. So 1 plus x square derivative will give you what? 2x. 2x. Close it down please. Let us see what it gives us finally. So this is cancelling. So you get only 1 here. And 1 minus, so tan inverse this thing, okay, 1 plus x square, okay. So let it be, so it is 2 and 2, 4, 4 with minus sign here, minus 4, x tan inverse x upon 1 plus x square whole square. This is the value of y2 which you are getting. Okay, so now please see what we can do here. Okay, and y1 is this much of thing. Okay, so do it. Let us find the value of x square plus 1 y2. X square plus 1 y2 will give me what? Minus 4 x square, but this will cancel. 4x tan inverse x upon 1 plus x square. Okay, and then this 2x x square plus 1 1. Let us see 2x x square plus 1 y1. What it will be giving me? Y1 is this thing. X square plus 1 when you multiply, this will cancel. This 2x, it is multiplying here is with 2x x square plus 1. So this x square plus 1 will cancel. 2 and 2, 4. So this will give me 4 tan inverse x into x. Please see. 2x x square 1. 2x x square plus this thing you multiply with this thing, so you get 2x. This thing will cancel, so 4x is done. So now add these two on the left hand side. Let us see what we get it. And this thing 4x tan inverse x. Okay, and you are getting 1x plus x square here. This we had to find it out. 1 plus x square. Y1 2 tan inverse x upon 1 plus x square. Okay, 1 plus x square. Y1 is how much? This thing. So 2x will give you this thing. 1x plus x square is coming. That is posing some difficulty. It is what? Let me just check it. It is y is equal to tan inverse x whole square. So 2 tan inverse x and the derivative of tan inverse x you have already kept it here. 1 plus x square. And so y2 will be what? 2, 1 plus x square whole square. And then 1 plus x square and derivative of tan inverse this thing. So it is 1 minus tan inverse x and derivative of how much? 1 plus x square, that is 2x. Okay. So it is 2x, 1 minus, it is 1 minus. Okay. Please see, this is the difficulty here. It is 2 also here coming. It is 2 also coming here. So 2 minus, please see, it will be 2. Y2 into x is just a minute. Please. I am doing it again, please check it. Here. It is y1 is 2 tan inverse x 1 upon x square. Y2 is what? 2 into this whole thing. Tan inverse x upon 1 plus x square. So denominator is square. And denominator, that is 1 plus x square. Derivative of tan inverse x, that is 1 upon 1 plus x square. Minus how much? Tan inverse x and derivative of 1 plus x square is what? 2x. 2x. Okay. So this is what you are getting. So it is 2, 1 minus 2x tan inverse x upon 1 plus x square whole square. So here it is 1 x. Oh yes, it is x square plus 1 whole square. We had to write it. It was okay. We were multiplying with this thing. So please see. Now we have done y1 is this thing, y2 is this thing. So y2 into, please see, 1 plus x square whole square is what? 2 minus 4x tan inverse x. This is equation 1. Now you have to add how much? 2x x square y1. So 2x x square plus 1 y1 is equal to what? Simply here you have to multiply with this thing. Here y1 is 2 tan inverse x this thing. So when you are multiplying with 2x x square plus 1, so this x square plus 1 will cancel and you will get 4x square inverse x. Please see when you are adding these two sides, these two will cancel and you will get 2. This is the answer. This is the answer. So this is all the questions which we have done. This was the question number 17th which we had tried. So this finishes your this next exercise. It is basically a practice exercise, nothing beyond that. Now see, we will take your next article, that is Rolle's theorem and mean value theorem. Rolle's theorem and mean values theorem. Rolle's theorem and mean value theorem. And mean value theorem. Now what these theorems have to say, please see. There is a statement you had to understand nicely. Yes. This Rolle's theorem, see, it's a good one, but only the thing is that proof is not given in your book, but that proof, of course, is a very difficult one, and then you come in your MSc classes, and when you read this compactness, etc., then see that mathematical proof is given. But intuitively also you can understand it. First let me give the statement of this thing, and then I will tell you that why such a thing actually happened. What it says, if f is a function, first see statement. Statement is very important. What it says is, if f is a function, if fx is a function on a closed interval, AB, such that three things should happen. Such that, number one, A, what first thing is one, that fx is continuous in the closed interval, continuous in the closed interval AB, in the closed interval AB, BC. Second, fx is differentiable, please, differentiable in open interval AB, and third thing is fa is functional value at these extreme points are equal, and say it is equal to 0. Say it is equal to 0, or simply say they are equal. Okay. In your book they say fa is equal to fb. They don't say this 0, so you can write here this thing. So if these three conditions are satisfying, then what it says, then Rolle's theorem says, then there exists a point C where in the open interval AB such that f dash c is equal to 0, f dash c is equal to 0. Means there the derivative will be 0. Now what does this precisely means, I will let you know. First of all, see, this is statement, you should know it. This is statement simply demands that a function should be continuous in the closed interval. See, what is more important is that the function is continuous in the closed interval AB and differentiable in the open interval AB. Please see, so what is the difference? See, function is differentiable, then obviously it is continuous. So function will be continuous in the open interval. If see you write that it is differentiable in the open interval AB, then it do implies that it is continuous in the open interval AB. But then see, what is more important is that it should be continuous at the extreme points A and B as well. So if this is happening and the functional value at both these extreme points are equal to each other, then see what it says, Rolle's theorem says is that yes, there do exist a point C in the open interval AB, PC in the open interval AB, such that the first f's derivative at the point C is 0. Now see, here I would like to tell you that how intuitively you will come to know that why such a thing is happening. why such a thing is happening. Please in fact see what it says. Here see you had to remember that what is this geometrical interpretation of the derivative. See if there is any graph here, at this point you are finding the derivative, then it gives you the slope of the tangent here. The derivative at a particular point of a graph, y equal to fx suppose is your graph and you are finding its derivative at say x naught. So dy by dx and x naught will give you what? The tangent you draw and its slope. That is, if it is making an angle theta with the positive x-axis, then the value of this tangent theta is precisely the value of the derivative at that point. So it gives you the slope of the tangent drawn at that point. So with this understanding, let us see what the geometrical interpretation of this Rolle's theorem turns out to be. See what it says is that there is a function. Suppose it is between a and b. Now it says that a functional value, suppose it is this much is functional value a, fa, and functional value at b will also be equal to a. Both the functional values here at a and b will be equal. They will be equal. Okay. So both these points will be part of this thing. And most of us see what is happening. That through in this thing between a and b, the function in the open interval a and b, the function is differentiable. Now differentiability demands that see everywhere on the curve you can draw a tangent. You can draw a tangent. See continuity demands that there shouldn't be abrupt change in the value. Like in modulus function, see in modulus function we have seen that at 0 the function is not differentiable. Why? Because see, if you at this particular point if you draw the tangent, then if you go on the right side then this line will be the tangent, and if you go on the left side then this won't be, this line will be the tangent. So at this point the function is not differentiable. So differentiability demands that you can draw the tangent at that particular point. Now see what actually happens in, now please look in. That here see if you are drawing with any curve, you please see draw any curve here. And then see you go going up, then you have to come down also. You have to come down also. And because see this is the point where you have to come. If you are going downwards, and then see at some point you have to come upwards also. You can in any manner, you can go like this, you can go like this, up, down, like this. Any path you can adopt. Any path you can go up, then you like this. So point is that see at one point the tangent will be parallel to x-axis. Tangent will be parallel to x-axis. Derivative is 0 at some point c. F dash c is 0 means at least one point you will certainly get between a and b, where see the tangent will be parallel to the y-axis. And please see to it that you try this thing. You take two values which are equal, and here see you draw a curve in such a manner that you have this thing, and you cannot draw a curve unless until you don't get one parallel tangent therein. Because see, it can't be the case. Like suppose you say you this thing, then see it will not be differentiable again. It has to be smooth. Here see tangent will not exist if you draw like this, though it is continuous, but it is not differentiable here. Sharp not, only see smooth bends are allowed. In differentiability, only smooth bends are allowed. This is the vital difference. In continuity, see, this is continuous, this curve, where you have this sharp. So you with a free hand, you have to go in. And you have to go in this thing, if you have to ensure that it is differentiable, then see, it is certain that see, unless until you don't get one point tangent here, which is parallel to x-axis, unless until you can't come to the same level of here, between 2 points A and B. So this is a good practice. And see, while mathematicians were doing it this way, they came to this conclusion of Rolle's theorem
only by simply observing the things. It is not like that they were doing whimsically. This is observation. In nature, see, it is not like that so many things you do, but you do whimsically. If you can reason it out, and that is, see, what is more important. In, see, this day-to-day life, whatever you perform, whatever you see, whatever you do, please let that be a learning, and that could be a learning only when you are serious about it. Good number of fundamental results in this thing, but later on, the rigorous mathematical proof for this Rolle's theorem was also given. So, mean value theorem is again, see, almost the generalization of the Rolle's theorem. It is nothing you will find interesting, and if you have certain skill, you have an interest. If you don't bug the things right away, see, I will tell you the statement of this thing. This is statement of mean value theorem. MV theorem, you also write it. It stands for mean value theorem, and it is nothing but the generalization of the Rolle's theorem. It again says if fx is a function or closed interval AB such that number same condition f is continuous on closed interval AB, and the second condition is f is differentiable on AB on open interval AB, then there exists, see, this symbol is what? Then there exists a C element of AB such that f tangent at the point C is equal to what? FB minus FA upon B minus A. I will show you what this thing turns out to be. But first you remember that what is this mean value theorem? It is the generalization of that thing. Because if you put FB is equal to FA, then numerator becomes what? 0. So it reduces to Rolle's theorem. So mean value theorem is the generalization of Rolle's theorem. So it is more generalized, and more generalized in the sense that, see what it has to see. I will tell you. Please see. This is this coordinate function. Suppose this is A, this is B, this is A0 mark, this is B0. The functional value here is this much, the functional value here is this much. Okay. Now see, from this point to this point, you have to go. This is FA, and this is FB. 0 FA, and this is 0 FB. Okay. Now see, you have to go from this point to this point. By any way you feel like. Suppose I am going like this thing, but mind it that it should be differentiable in the open interval AB. That is, your graph should have a smooth curve. See, I tell you, derivative, and this is smoothness. Smoothness is a term, mathematical term, which simply demands that curve is said to be smooth when it has got, when you can draw tangent everywhere at each point in the given interval. So if f is differentiable in the open interval AB, then throughout on this graph, the function, this graph should have tangent at each point in the open interval AB. So mind it that this should be smooth, means there shouldn't be sharp bends like in the case of the modulus function. This is sharp bend. A smooth bend is like this thing. It's smooth. If you are going like this thing, it is smooth. There couldn't be very sharp bends. So its smoothness, later on when you will come to this higher algebra, this differential calculus, then you will see that smoothness simply demands that you shouldn't have sharp bends. Okay, only smooth bends are permissible in the graph. So this is smooth bend. And what it says, FB minus FA is what? Please see. So you join this point, these 2 points. Then please see and draw this triangle. Then this tangent, this is how much? Suppose this is M, this is P, this is point Q.
Then in the triangle PQM, this is theta, that tangent theta is nothing but FB minus FA upon B minus A. That is this line joining these 2 points. These 2 points, the extreme points, A, what is this point P? It is having coordinates what? A, FA, and this has got points B, FB on the graph. So here see, if you join this line, then what it simply says is that somewhere here a point C will certainly exist where the tangent will be parallel to this line. I am joining point P and Q, and point P and Q are what? These points correspond this on the graph corresponding to A, FA and B, FB. So what it says is, if you join these 2 points, then the slope of this line is what? FB minus FA upon B minus A. So what it says is that yes, in between on the graph, you will certainly point a point C where the tangent will be parallel to the line joining the extreme points on the graph of function y equal to fx. At least one point will certainly exist. You can have more than one point. Likewise in Rolle's theorem, you can have more than one point. But at least one point will certainly exist, provided function is continuous in the closed interval AB and differentiable in the open interval AB. Differentiability demands what? You shall have tangent everywhere in the open interval AB on the graph. That is to say, you shouldn't have anywhere these sharp bends on the curve. Only smooth curves are permissible. And this thing, see, you can always try. You from this point, you go by any means, like this thing, you go but smoothly, without any bends. Then see, you will certainly find that 2 points here, where the tangent will be parallel, 1 point at least. But see, you can try it, rather here you will have 3 points. Wherever you are going up and down this point. It should be a smooth curve. Smoothness means you should have tangent. So you will here, as a matter of fact, if you go like this, you will have 3 points in between. So point is, but if you are going straight away like this, then you will have only 1 point. You can have multiple points. You may have infinite points. If you are going from this on this line straight away, so you will have infinite points where everywhere the tangent will be, slope of tangent will be same as the slope of the line joining the point P and Q. What are these points P and Q? Points on the graph corresponding to A and B. A and B. So this is the statement. So this is the statement. Now, based on this thing, we will see that questions are too simple. And but see, what is more important is that how people have come to this conclusion and statement of the Rolle's theorem and mean value theorem. It is simple geometrical observation of the graphs, nothing beyond that. But again I repeat that there is a rigorous mathematical proof for it also, which is given in MSc classes, and it is based on the concept of compactability and this general theory of metric spaces. So without taking much time, we can try the question. Every year you have 1 or 2 questions therein. So exercise 5.8, we can take it here. Okay, we will take it other day. In fact, I was not knowing it, and I will be telling you all my students that next time I will be at exactly at 8. I was accustomed to this 8:30 timings, but all of a sudden Professor told me that it will be class will be from 8. So next time, please be